So I've been asked if I can do a video on solving radical equations. I'm going to go through some square root equations. I'm going to go through some cube roots, fourth roots, some higher order roots, and we'll just go through the step-by-step process. You should take note of the process that we're always going to use to solve these problems. The first thing you always want to do is isolate the radical. Whether it's a square root or a cube root, get that by itself by doing the opposite of what's going on around it. And when we isolate it, remember we have to use the order of operations. So we have to cancel out addition and subtraction before we can cancel out multiplication and division. After the radical is isolated, to cancel a regular old square root, you can just raise both sides of your equation to the second power. To cancel out a cube root, you can raise both sides to that power. So I'm going to say raise both sides to whatever order, or sometimes I say whatever index your radical is. What I mean by that is, if you're taking a square root, and by the way, if you don't see an index, if you don't see a number next to the radical, we're always going to assume that it's just a square root. What I mean by rule 2 is, you have to raise both sides of the equation to whatever number falls next to the root. That is what is known as the inverse operation of a root. It is a power. Inverse of a root is a power. So we have to raise things to different powers, or exponents. So our first step for number 1 is, when you look at equation number 1, nothing is going on that's not underneath this radical sign. The entire left-hand side has a radical sign over everything. So what I mean is, the radical is already isolated. It's by itself. That means we can start to cancel this by raising this to the second power. I'm going to raise both sides to the second. The left-hand side remains what was underneath the radical to begin with. Whenever you take a square root and then you raise that to the second power, those two basically erase each other. So we're left with x plus 6 equals 9 squared, which is 9 times 9 or 81. To solve for the value of x, you subtract 6 from both sides. And you get x equals 81 minus 6 is 75. The second one is also already isolated, so we can start off by just squaring both sides, or raising both sides to the second. This leaves me with 3x minus 1 equals 8 squared, which is 64. This equation, we can't forget our basic rules. We have to cancel out addition and subtraction before we can start dividing or multiplying to cancel those out. So let me add 1 to both sides. You do get 3x equals 65. And divide by 3. Does not divide evenly. It comes out to be about 21.6 or 21.7, however you want to round. But let's not round. That's a good answer, 65 thirds. I've noticed a lot of people don't like improper fractions. They prefer mixed numbers or decimals. But I just want to let you know this is a valid answer. It's okay to have improper fractions. Okay, 2 more square root equations. So if you notice on number 3, this is one where the square root is actually not isolated. There's this 2 being multiplied, there's this 6 being subtracted. So there's operations going on around the square root. We need to cancel them in the same order that we would normally if we just had a variable there. So the minus 6 needs to be canceled first. And to do minus 6 would be plus 6 to both sides. End up with 2 times square root of x plus 1 is equal to negative 2 plus 6 gives me a positive 4. Continue to solve. Cancel out your multiplied by 2 by doing divided by 2. So those will cancel. And you're left with the square root of x plus 1 is equal to 2. 4 divided by 2 is 2. Now that we have the radical isolated, we can raise to the second power. So raise both sides to the second. I'm left with x plus 1 equals 2 squared, which is 4. Not solved yet because I need to subtract 1 to get the value of x. The value of x is positive 3. By the way, you should always go back and plug those numbers in. Sometimes you can do it in your head, sometimes you can't. If you plug this 3 in here for x, just to test out the solution, it does end up working out. And for some of these, you actually do need to plug them in, especially if you get more than one answer, just to make sure that it's correct. Square roots can have what are called extraneous solutions. And what that means is you solve it out correctly, but you get one answer that if you plugged it back in, it would not work. So we need to be aware of that. On number 4, the square root's already isolated, not too hard, so square both sides. Underneath the radical, we had this x squared plus 11, so it's still there. The radical's gone. The x squared plus 11 is still there. And on the right-hand side, it's 6 squared, which is 36. So solve it out. What's funny about this is when you square both sides, you end up with a quadratic. And this is a quadratic since it has x squared. We have to take note of that because it may or may not have 2 solutions. This one actually does. 36 minus 11 gives me 25. These are nice numbered solutions as well. Since 25 is a perfect square, when you square root both sides of this to solve it, you do end up with x equals positive or negative 5. You will find out if you plugged in positive 5 or negative 5, both of those would give you a valid conclusion. Moving on. You do have roots besides square roots. There's higher powered or higher ordered roots, such as a cube root, fourth root, and things that we'll see here. This, number 5 and number 6, are both cube root equations. And we're dealing with cube root equations. We do have that same process where you need to isolate the radical, but instead of squaring both sides, instead of raising both sides to the second, we are going to raise both sides to the third. Number 5 has the radical isolated already, so let me take this whole thing, raise it to the third. Whatever you do to one side, you have to do to the other. This cancels the cube root, so I'm left with just 2a equals. And then 4 raised to the third power is 4 times 4 times 4, which gives me 64. Solve this out for a. This is multiplied by 2, so divide by 2 to cancel. And a is equal to 32. Number 6 is 5 plus the cube root of a equals 1. So again, we want to get that cube root of a by itself. So subtract this 5. This 5 it doesn't belong there. We need this by itself. And this is influencing it. Left with the cube root of a equals 1 minus 5, which is a negative 4. One thing about square root equations is that they can never equal a negative value. It's due to what's called the restricted range of the square root function. Square root function's range is only positive numbers, not negatives. The thing about cube roots, though, is the cube root function does not have a restricted range. The range is all real numbers. So we can actually solve this. To solve this, to cancel the cube root, you raise to the third power. With negative 4, the entire thing gets raised to the third power. This leaves you with a equals, and the negative 4 to the third, that's the same thing as saying negative 4 times negative 4 times negative 4. Since we're multiplying it an odd number of times, the answer comes out negative. Let me show you why. A negative times a negative gives you a positive 16. Then if you multiply positive 16 by negative 4, you end up getting negative 64. So negative 4 raised to the third gives you a negative 64. And that's your answer.